Imagine a city rocked by a blast so powerful it shook buildings miles away. This is the story of the Tianjin port explosion. Assalamualaikum and good day everyone. Today I will briefly explain the general background of the Tianjin port explosion that occurred on the 12th of August 2015, which is considered one of the most catastrophic industrial chemicals incidents in modern history. The incident took place at the hazardous goods warehouse operated by Ruhai International Logistics. Located in the Binhai New area of Tianjin Port, one of China's largest industrial and shipping hubs. The warehouse had been operating since 2011 and has involved in the storage, transportation, and distribution of various hazardous chemicals, including toxic, flammable, oxidizing, and corrosive substances. However, the facility was operating in violation of national safety and zoning regulation. According to this regulation, hazardous chemical storage facilities must be located at least 1 kilometer away from residential areas. In this case, the warehouse was situated only about 500 meters from nearby housing, significantly increasing the risk of the surrounding population. On the night of the incident, at 10:51 p.m., a fire broke out in the warehouse delivery zone. Within 43 minutes, the fire escalated into two massive explosions. The first one was equivalent to around 3 tons of TNT, and followed by a much larger second explosion equivalent to around approximately 21 tons of TNT. This explosion caused widespread destruction over several kilometers, resulting in a severe environmental contamination and a high number of casualties. Subsequent investigation revealed that more than 11,300 tons of hazardous substances were illegally stored at the site. Yes, and these included nitrocellulose, sodium cyanide, ammonium nitrate, and various oxidizing agents. The investigation concluded that the accident was triggered by the spontaneous combustion of improperly stored nitrocellulose. This initial fire then set off a chain reaction involving other highly hazardous chemicals, leading to the devastating explosions.
Next, details of chemicals involved and possible reaction. The Tianjin port explosion of 2015 occurred at the hazardous chemicals warehouse in China. It is caused by improper storage and handling of dangerous chemicals. The incident involved multiple reactive substances, which is leading to a large-scale explosion. It also demonstrates the risk of chemicals incompatibility and poor safety management. Next, ignition of the fire. Fire likely initiated by self-heating and ignition of nitrocellulose. Also, high temperature caused rapid spread of fire. Next, fire reached nearby storage containers containing reactive chemicals and also created conditions for secondary chemical reaction. Next, there are several chemicals involved. The first one is ammonium nitrate. It is a strong oxidizer, explosive when exposed to heat and shock. Second is calcium carbide. It is a water reactive substance. It produces flammable acetylene gas. Next is sodium cyanide. It is highly toxic and forms hydrogen cyanide gas upon contact with water or acid. The last one is nitrocellulose. It is highly flammable solid and can self-ignite at high temperature.
For properties of chemicals, the first one is ammonium nitrate. It is white crystalline inorganic salt and also highly soluble in water, which is hygroscopic. It also a strong oxidizing agent and thermally stable at room temperature, but it can decompose violently when heated or confined. Explosion risk of these chemicals increases with contamination. The second one is potassium nitrate. It is white crystalline solid and also an oxidizing agent. It non-flammable but supports combustion. It's stable under normal condition but can intensify fires when mixed with combustibles. The third one is sodium cyanide. It is white water soluble solid and highly reactive with acids. It releases hydrogen cyanide gas upon contact with moisture or acids and chemically unstable in fire condition.
Hazards of Tianjin port explosion video. First, toxic contaminants. For example, like cyanide compounds, carbon monoxide, nitrogen oxides, and sulfur dioxide were detected at the site, posing inhalation and water contamination concerns. Next, we have hazardous dust and debris. From explode containers pose potential exposure workers and vessels in the port area. Lastly, we have pollutants in drainage, water bodies and risk fears of contamination leading to monitoring and river or ocean outlet closures. This is the example of Tianjin port explosion video on that time.
Move on to the next part. I will discuss the toxicity information of the Tianjin port explosion. The accident raised serious toxicological concerns due to the massive quantity of hazardous chemicals stored at the site, particularly sodium cyanide. Approximately 680 tons of sodium cyanide were present, far exceeding regulatory limits and posing an immediate threat to humans' health and the environment. Sodium cyanide is extremely toxic, and when it comes into contact with water or undergoes decomposition, it can release hydrogen cyanide gas, which is highly lethal. This compound interferes with cellular oxygen utilization, potentially leading to respiratory failure and other severe systemic effects. Environmental monitoring conducted after the explosion revealed severe contamination within the exclusion zone. Cyanide levels in nearby water bodies were recorded at several hundred times above acceptable safety limits, with some samples measuring up to 356 times higher than the allowable threshold. Although cyanide concentration outside the restricted area were reported to be below dangerous levels, traces were still detected in surrounding waters, requiring containment measures to prevent further spread. In addition to cyanide contamination, toxic gases and vapors were released into the atmosphere, causing severe air pollution in the central accident zone. Elevated concentrations of hydrogen cyanide, sulfur dioxide, hydrogen sulfide, and ammonia were detected, exceeding legal safety limits by 1 to 4 times. The explosion also resulted in significant soil pollution, with localized exceedances of cyanide and arsenic levels, posing long-term risks through groundwater contamination and uptake by plants.
During the Tianjin explosion, several dangerous chemicals caused serious health and safety risks. Ammonium nitrate could cause breathing problems and eye irritation, and although it doesn't burn, it's a strong oxidizer that can explode under heat, pressure, and contamination. Sodium cyanide is extremely toxic, leading to dizziness, breathing failure, or death, and can release poisonous hydrogen cyanide gas that spread easily in air and water. Potassium nitrate irritates eyes, skin, and lung, and as an oxidizer, it makes fire burns hotter by releasing oxygen at high temperature. Next is calcium carbide. It causes skin and eye irritation and react with water to produce high flammable acetylene gas, creating a risk of secondary explosion during firefighting. Finally, sodium sulfide can burn skin and eye, harm breathing, and release toxic, flammable hydrogen sulfide gas when exposed to heat, moisture, or acid. Together, these chemicals make the disaster extremely dangerous for both people and environment.
Further contributing safety failures in Tianjin port explosion, we have 4 safety failures. First, the mixing of incompatible chemicals in the same area. Next, we have the sites also suffer from inadequate risk control and registration procedures. Next, exceeding legal storage capacities for hazardous materials. And lastly, the biggest failures is systemic problem in chemical storage and industrial safety management contributing to the explosion.
Next, regulations related to the use of the chemicals in lab or industry. Regulation on the use of hazardous chemicals. Hazardous chemicals must be properly classified, labeled, and documented. Compliance with the globally harmonized system (GHS) is required for hazard communication. Risk assessment must be conducted before handling or storage. Only trained and authorized personnel are permitted to handle hazardous substance. Incompatible chemicals must be stored and handled separately. Next is key regulation in laboratory and industry. The first one is Occupational Safety and Health Act 1994 (OSHA 1994). It ensures a safe working environment in labs and industrial facilities. Next one is USECHH Regulation 2000. It controls exposure to chemicals hazardous to health and also requires exposure monitoring and control measures. The last one is Class Regulation 2013. Implements GHS in Malaysia. It also requires proper labeling and safety data sheets. This may conclude that failure to comply may result in fire, explosion, toxic releases, and legal action.
Now let's move on to the impact of the accident to people's health. First is immediate effect. 173 deaths, including firefighter and responder. Many suffered burns, fracture, trauma, and breathing problems from toxic chemicals like sodium cyanide. Next effect is short to medium, includes respiratory impact and psychological impact. For respiratory issues or impact, it consists of presenting cause, worsening asthma from smoke, dust, and fume. For psychological impact, PTSD, anxiety, depression, stress, and sleep disturbance for evacuees is under all physically impact. For the last effect is long-term effect. This effect include risk of chronic respiratory illness from ongoing exposure to toxin, mental health concern due to fear of chemical contamination, no need for regular health monitoring for nearby residents. As for the impact for environment to this Tianjin explosion is include three effects, which is air pollution, water pollution, and soil contamination. First is air pollution. Its release of toxic gases like nitrogen oxide, NO and NO2, and hydrogen cyanide HCN, thick smoke and chemical dust lowered air quality, posing health risks. Nitrogen oxide contribute to acid rain, harming buildings, crops, and habitats. For water pollution, sodium cyanide leak into waterways, threatening drinking water and aquatic life. Cyanide toxicity require emergency neutralization to prevent widespread contamination, highlighted the vulnerable of water resources to industry chemical accident. For the last effect is soil and ecosystem damage. Soil contaminate with nitrate, cyanide, and chemicals, risking underground and agriculture. Fish kill, aquatic disruption, and vegetation damage reduce biodiversity. Heat and chemical exposure cause long-term ecological harms.
Lessons learned from the accident. The first one is proper segregation of chemicals, which incompatible chemicals such as oxidizers and flammable materials must be stored separately to prevent escalation during fires. The second one, safe storage quantity and location. The large amounts of hazardous chemicals should be limited and stored far from residential and populated areas. The third one, accurate chemical documentation and labeling. Emergency response depends on correct information about stored chemicals and their properties. The fourth one, chemical-specific emergency response training. Firefighters must understand chemical behavior to avoid action that trigger reactions or explosions.